In this video, I will be talking about how to use Vernier graphical analysis to linearize curved data to create a mathematical model. So linearization is a process by which we can take data which has a curved relationship and plot something that's a straight line. And the reason we might want to do this is because once we have that straight line, we can see whether or not we have a direct proportion, and we can see how the variables are truly related to one another. And so I'm assuming you already know how to create a position versus time graph using Vernier graphical analysis here. And now I want to show you how to linearize things, how to straighten out this curve so that we can represent the same data as a line. And this relationship will then help us build a mathematical model using our line tools that we are already familiar with. And so you have a graph that looks like this. And on this graph, we can see the position data is growing more rapidly than the time data, right? That's why it curves upward, is that the position grows at a faster rate than the time is growing. And so to linearize this, we need to do something. We need to do a calculation which will help the time data catch up to the position data. So the position data is growing faster. We need to help the time data catch up. We see that the shape of this graph looks like a quadratic equation. It looks like a parabola. And so that indicates that we may want to square the time data to help it catch up, right? A number squared, if it's bigger than 1, is going to be larger. And so we want to square this time data. We could grab our calculator, go through 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, all throughout all of these numbers, or we could have graphical analysis do all of that for us. And so if we go to our data table, I want to square the time data, so I'm going to click the 3 dots next to where it says time. After that, I'm going to add a calculated column, not a manual column. That would be if I was typing in data manually. Here, I want graphical analysis to do some math for me, so I'm going to add a calculated column. This calculated column is going to be time squared, so I'm going to write time caret 2 for time squared. The caret is shift 6 on your keyboard. And then time was measured in units of seconds, so time squared we measured in units of seconds squared. And I want to insert the math expression I'm going to use to calculate this now. I'm going to look at all of the different math options I have, and I want to raise something to an exponent. And so a and b are constant values in all of these. Here, a times x to the b will be, I can put a coefficient in front of my data, and I can raise it to some exponent. X is data that I can insert here. So I want the a times x to the b. And parameter a, I just want it to be 1. I don't want to multiply by a coefficient. The x, I want to be squaring the time data, and then the caret here means I'm going to raise it to the second power. And this should square all of my time data. So I'm going to take 1, multiply that by time squared. And I apply, and I now have my time squared data. I want to make sure it makes sense. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So that all makes sense to me. With your data, where you won't be able to square them in your head very easily, it's probably smart to double check 1 or 2 of them with a calculator to make sure that the computer did what you wanted it to do. And now that we have time squared data, all we need to do to plot this data on the x-axis instead of time is click the x-axis and change from time to time squared. And now we have data that's position on the x-axis and time squared measured in seconds squared. Sorry, on the y-axis we have position. On the x-axis we have time squared measured in units of seconds squared. It's still doing a quadratic fit, which I don't want anymore. I can see by squaring the time data, I've helped it catch up to the position data, and I now have a linear relationship. Now I can go to my curve fit, apply a linear curve fit after xing out of the quadratic curve fit. And here we go. Here's my linear relationship. And so I can create a mathematical model now which relates position to the square of time, to time squared. When I go to write this in my lab report, instead of y, I'm going to choose a variable that represents position. Instead of x, I'm going to choose t to the second power, because time squared is what's plotted on my x-axis for this linear relationship. So this x should be replaced by time squared. When I do m, it should be whatever value you get for m here, and then it should have its appropriate units. The units for the slope are always y-axis units, which are meters here, divided by x-axis units, which are seconds squared. So your slope units should be meters per second squared. If I were using this data, I would replace the letter m with 1 meter per second squared. And the b value is your y-intercept value. Because of the fact that my data is fake, this ended up being exactly 0. Yours will be something else. And your y-axis units should be, your y-intercept units should be whatever's plotted on your y-axis. So meters is the y-axis unit, so the y-intercept should be 0 meters. So I would replace b with 0 meters if I were creating a mathematical model from this data. This is how you linearize curved data. You need to square whichever set of data needs to catch up. Here that was the x-axis, sometimes that's the y-axis, sometimes need to invert things, but you always need to do something to help the data look like a line. That shows us the direct proportions we have between different variables, and then you can create a mathematical model from that linearized data. Oh, I almost forgot. The title here is wrong now. I need to fix the title. So graph options, edit graph options, position versus time. On that horizontal axis, I now have time squared. It's easy to forget that. You'll notice I almost forgot that in the video here, but I will be looking for that when grading graphs. And so you need to make sure your title accurately reflects what's plotted there. Don't forget to change it. All right, now that concludes my linearization video for how to linearize data using graphical analysis.